Hello, we are Beats by UTD. I'm Calvin Nance, the team lead and system designer. This is Michael Simpson, the embedded software engineer. This is Josh Matthew, the human interface designer, and Anquan Nguyen, the data storage engineer. We built a personal audio testing platform for liquidity services. They currently get returns from people returning their Bluetooth headphones, and they test them by hand to make sure that they work, and then they resell them by bulk. Currently, that process takes about 4 minutes per headphone. We made the testing platform run at 5 minutes per headphone, but in parallel with 8. So that saves about 66% in time over 8 headphones. And here's Michael with our hardware parts.
For our platform solution, we created a modular 3D printed design that houses our different microcontrollers that we use for this process. We have 3 different microcontrollers that we use for the capabilities of NFC, for Bluetooth, and then for also handling any of our audio for being output to speakers or being read from different microphones for reading the values that we're testing for. Throughout the process, for the hardware, we have a number of integrations that we've done, and this system also pairs up to the tester's workstation computer. So they have software that they're going to be using on that's going to be giving them all of the steps through testing each individual headphone that they're putting on the stand, as well as integrations to the specific customizations that we make for different headphones at different times. Next, Joshua is going to be talking about that GUI and that computer system.
So our graphical user interface is written in a universal Windows platform, which is like a built-on add-on to Microsoft Visual Studios. So our code implements the unit tests, which are displayed on the right-hand side of the slide. And these unit tests are initiated whenever the operator scans in a barcode for their headphone object that they want to test. And by using TCP over IP communication protocol, that's how we send and receive our commands to be able to run our different unit tests. And Anquan will talk about our data storage aspect.
Okay, so for our data collection storage, we're using a database that mimics what liquidity services will be using in their testing environment. From the database, we're getting a device model number that will help determine which of those unit tests that need to be performed on a specific device that we're testing. And when we're done with testing, we store back into the database a very quick and easy, simple glance visual format, as well as a more detailed JSON format. And Calvin will conclude the presentation.
We hope this helps our sponsor test more headphones more effectively. And are there any questions?
Yeah. So how do you verify that the reception microphone is flat? In other words, how do you prove that you're actually getting linear frequency response from 20 kilohertz to 50 hertz?
So the design that we have for the 3D print is specifically modeled for the microphone chip that we're using and the microphone board. So it's sliding it in so that it is going to be parallel, and then also that piece slides up into that headphone stand and locks into the top. So we are ensuring our positioning of the microphones in that way. For the graph and those are generated off of the signals that we're reading and that we are processing from those microphones.
Were you able to test the flatness of that microphone by running a really linear sound generation system put right beside that microphone? Did you able to test
So
that?
actually the test that we do, we have a frequency sweep that we do. So we're generating just a specific frequency from the headphones. And those are going to be the different values that you're seeing in those different points.
Okay. How do you follow up on the question, how do you correlate the tests that are run at manufacturing time with what you're doing here?
So we don't really correlate the manufacturer tests and those kind of things that are being run. Liquidity is a separate service that is specifically for just the return headphones. So Liquidity has a standard of quality that they hold of their own for the grades and what they're going to resell or what they're going to put for parts and that kind of thing. So Liquidity establishes their grading system and their quality that they're looking for in the headsets themselves.
So how did you compare to humans doing the same thing?
And just the amount of time it takes
I mean, the
So-
quality, were you able to find the same problem or come up with the same answers, the human, or better answers? Or?
Yeah, so we were provided headsets that had known issues from Liquidity, and we were able to basically have those headsets fail for those same reasons. When
Okay, I'm glad they
it was
kept
going through
those
our
and didn't
tests.
send them to me. Thank you.
Last question. Did you have any limitation? Any limitation
On what?
for testing range?
So the only limitation that we really faced for our testing was mainly going to be the time frame that we were going to be testing in, because the main purpose of this project is going to be to help kind of the testing flow and to do that. With our design, we're able to introduce new tests or adjust current tests, such as with the frequency sweep, where at one point we had it sampling about 9 or so different frequencies in a full range of something that you're never going to hear put out of a headphone into something so high pitched that nobody would want to hear it. So we had pretty flow or pretty free ability on that. But we had to scale back the scope of what we were doing simply for the time that it takes and the actual applicable tests that will really need to be run.
Okay, we'll need to stop there. Thank you very much.